All right, hello again, everybody. This is the third and final video for section 1.5. I know some of these videos have been a little bit longer. That's just partially because the section or the content of 1.5 is probably some of the more complex we've done thus far. Okay, so for this section, we're going to continue on talking a little bit more about vertical stretches and compressions and horizontal stretches and compressions, and then look at putting kind of all of these different transformations we've been talking about all together here. All right, so on this problem we are given here, we're told, this is similar to ones that we did in the previous video, where we have a table for a function f, and they want us to create a table for the function g that is given by 1/2 times f of x. Now notice, this 1/2 here is being multiplied on the outside of the function, right? So that's how we know it's a vertical stretch or compression, because it's happening on the outside. And recall, because it's happening on the outside, it impacts the outputs of the function. So when we go to make our table for the function g of x, what it'll look like, well, first of all, it's on the outside, so it's impacting the outputs, so the inputs will stay the same. So we'll still have the points 2, 4, 6, and 8 here. The numbers 2, 4, 6, and 8 as our inputs. But then the outputs now are going to get changed. The 1, the 3, the 7, and 11. Okay? And let's think about how this happens. So remember, if the number is being multiplied on the outside, it impacts the outputs in exactly the way you would think. So having that 1/2 there means to multiply each of the outputs by 1/2. So we could do 1 times 1/2, which would give us an output of 1/2. 3 times 1/2, which would give us an output of 3/2, or 1.5. 7 times 1/2, which would give us an output of 7/2, or 3.5. And 11 times 1/2, which would give us an output of 11/2, or 5.5. Okay? And that would now be our table for the function g. And just as we did before, let's kind of visualize what's going on here. And this time I'm going to use the point 811. Okay. So because that 1/2 is on the outside and it is less than 1, this is going to compress the point, okay, vertically, so kind of smush it down. And when we do that, notice that the input, the 8 stays the same, but the output, the 11, is going to get cut in half. So that's where we get that 11/2, and that's what that's supposed to say. Okay, so that's how this point 811 becomes the point 11/2, excuse me. And we could do the same thing for all the other points. All right. Let's look at now what would happen if we try to write the equation of a function where now the 1/2 is on the inside of the function, right? So let's look at that. So here, we're still going to set up our table as x, g of x. And recall, if it's on the inside, it impacts the inputs this time. So our outputs will stay the same, so they'll still be 1, 3, 7, and 11. But the inputs are now going to change. And recall that because this is on the inside, it's part of the house of lies, so it does the opposite of what we would think, right? So here, rather than multiplying all those inputs by 1/2, right, recall that it'll actually impact them in the opposite way. And so all of these will get multiplied by the reciprocal of that. So instead of 1/2, it'll become 2/1, which is the same as 2 will be our factor. So we go through and multiply each of these. The 2 times 2 gives us a 4. 4 times 2 gives us an 8. 6 times 2 gives us a 12. And 8 times 2 gives us a 16. So the table for our function g in this case looks like inputs of 4, 8, 12, 16, and corresponding outputs of 1, 3, 7, and 11. Okay? All right, and again, to kind of visualize what is going on here, we'll again use the point 811. Oops. Okay, so that's here. And because, again, that 1/2 is on the inside, and sorry, let me put that 8/11 in a different spot. So the point 8/11 is right here. Okay, that 1/2 is on the inside, impacts the outputs, or inputs, excuse me, which moves things left to right. And because it's a 1/2 between its 0 and 1, it does the opposite of what we think, so it actually stretches things horizontally. And so when we do that, the point gets stretched out, and when we do that, the output stays the same, so the output is still 11, but the input gets doubled, so in this case we get the point 1611, which is what we see here in our table. Okay? All right, now the next thing I'm going to look at then, now that we have all of these different types of transformations, is what order, if we have a combination of them, what order do we do them? So we're going to look at vertical and horizontal transformations separately, but then we'll go look at what happens when we have them together. So for combining vertical transformations, and this means stuff on the outside of the function. So we have, say, a number multiplied on the outside and one also being added or subtracted. Well, the order we do things, we first do the stretch, so what the value of a, the number being multiplied, tells us to do. And then we do the shift, the vertical shift up or down, so what the value of k tells us to do. Okay, so stretch, then shift. When we're doing horizontal transformations, okay, so this is the stuff on the inside. First things first, we need to make sure that our function, or the inside of our function, is written in this factored form. And what do I mean by that? Well, if we look at our function, it's written as something of f of x equals 2x plus 4. Well, we cannot say, if we're matching it up with this form up here, that b is 2 and h is 4. Okay, that doesn't work. We have to first write this as in a factored form, which means on the inside, notice that the 2 and the 4 have a number in common. And actually, really what's important here is we want to try to get the x alone. So in this case, we could factor out a 2, which if we do that, taking the 2 out of the 2x just gives us x, taking it out of the 4 gives us a plus 2. And notice now this is in a factored form where it's a number times x plus or minus something. Okay, and more importantly, the x is alone. So we have to write it in that form first. When we have it like that, then what we do is similar to above, we do the horizontal stretch or compression first. So based on what the value b tells us to do, and notice, remember, it gets stretched by the reciprocal of that value for b, so that's why it says 1 over b. And then we horizontally shift by h, so shift left to right depending on what the value of h tells us to do. Okay, so in similar order as above. And a really cool thing about transformations is if you have both vertical and horizontal transformations together, so let's say your function looks something like this. You have like a 2 times f of x, or sorry, f of 3 times x plus 1 minus 2 on the outside. So notice we have the -2 and the 2 here are vertical transformations, the 3 and the 1 on the inside, so those are horizontal transformations. You might be thinking, crap, what do I do first? Well, as it says here, it does not matter. Okay, so you can do them in either order. You can either do the horizontal transformations first, then the vertical ones, or vice versa. Okay. All right, so putting this together then, let's do a transformation of this function here. So notice they didn't give us a formula here, but this kind of, snake looking thing here, that's going to be our graph or our function. So that's the function f of x. And notice over here on the right, they've given us some transformations of f. So notice there's a couple of numbers on the outside and then some numbers on the inside, right? So it's going to be both horizontal and vertical transformations. Okay, so as we just saw, it doesn't matter whether you do the horizontal or the vertical transformations first. So I'm actually going to start on the inside and do the horizontal ones first. And recall that what it told us to do first was to deal with this 1/2. So that's the first thing we're going to do. Now it's a 1/2. It's on the inside, so it's a house of lies. So even though it's a 1/2, it's actually going to, so a number between 0 and 1, it's actually going to stretch my function left to right horizontally, right? And remember, when it stretches it by a factor of the reciprocal of 1/2. So it's going to factor it or stretch it by a factor of 2/1. Also, because this is on the inside, it's only going to impact the inputs. So here's how I figure out what that does. So I'm going to look at primarily these points here. Okay, all those ones I've circled. And look at the outputs there, or the inputs there, sorry. So for the first one there, the input is -2. If I stretch that by a factor of 2, that'll make a -4, and I'm not moving up or down, I'm not changing the outputs. The next one I've circled is at a input of -1. So if we double that, we get -2. The middle one is at an input of 0. If we double that, well, we just stay at 0. Next one is at an input of 1. If we double that, we get 2. And the last one here is an input of 2. If we double that, we get 4. And so then, now if I draw out the new graph, connecting all those dots in green there, notice hopefully you can see how the function has been stretched horizontally, right? It's like we took each in and pulled them in opposite directions. All right. Next thing then we're going to do is deal with this -1. So that's going to be our second thing. And it's a -1, but it's on the inside of the function. So recall, what does that tell us to do with the function? Right, that tells us to shift it to the right 1 unit, right? So it's a house of lies. Even though it's a -1, it means go to the right. So what I'm going to do is take all these points, the ones that I had before, and I'm going to shift them all to the right one. So this one goes here. This one goes here, this one goes here, this one goes here, and then this one actually can go off our graph to here. Okay, and again, if I connect the dots in blue, notice we get this blue function here that is the same as the previous one, just everything shift to the right 1 unit, right? Okay, and to avoid confusion, I'm actually going to erase the green graph now just so we can see what's happening. Okay, so we're now in this blue graph. We've dealt with all of the inside transformations, so let's now go to the outside. So we have that 2 and that 3 on the outside. Recall that we just learned a second ago was that to deal with those, we deal with the 2 first, so the stretcher compression there. Now that 2 is on the outside, which means it's going to impact the outputs at our points. And also because it's on the outside, it's going to do exactly what we would think it would do, right? So it's a 2, which means it's probably going to make things bigger, which means it's going to multiply our outputs at each point by 2. Okay, and that's going to be our third step. So looking at this point, this point, this point, this point, and this point, I'm going to look at the outputs and double each of those. So for the first one at -3, well, the output is 0, so doubling that leaves us at 0. At the second point, the output is -1, so doubling that gives us a -2. Back at the point at 1, 0 there, the output is 0, so doubling that gives us a 0. At the point 3, 1, the output is 1, so doubling that gives us a 2. And then here at the point 5, 0, doubling the output there leaves us at 0. Okay, so what we end up with then is this orange graph. And hopefully when you compare that to the blue one, okay, it makes sense what we see, right? So the 2 on the outside should do a vertical stretch, so it's like we're pulling from the top and bottom and pulling in opposite directions. And it looks like to go from the blue to the orange, that's exactly what happened, right? Okay, so now I'm going to delete out the blue, so we're on the yellow now. And what colors do I have left that I can use? Let's go with a pinkish. All right, so now we deal with the +3. That's going to be our last step there. And remember, the number being added or subtracted on the outside means to shift vertically up or down. And because it's a +3, it's going to tell us to shift up 3 units, right? So we'll take each of our points here and shift them up 3 units. So take the -3, 0, go up 1, 2, 3, it goes to here. The -1, -2 goes up 1, 2, 3 units, ends up here. The 1, 0 goes up 1, 2, 3 units. It'll end up here. The 3, 2 reshifted up off my graph to a point that would be like 3, 5 way up here. And the 0.50 gets shifted up 1, 2, 3 units to here. And so our final graph there then would be the pink one there at the top. And I hope that's pink. I'm a little colorblind, so I may be wrong. You guys can tell me if I'm wrong or not. Okay, so that is step-by-step performing all of those transformations and kind of seeing how they impact the graph along the way. All right, and so if I were to erase out all of this stuff, the pink graph there would be the one described by this function here. Okay, so the 2, starting with the function f of x, which is the one in black, doing the 2 times f of 1/2 times x minus 1 plus 3, that gives us the pink graph. All right, great, that's the end of section 1.5. Thanks for watching.